Hmm. Okay, it seems I'm live. Okay, so I will start at 9:15 as it was timed. Sorry for the late, guys. Well, there is no one to be sorry about. আমার আওয়াজ কি শোনা যাচ্ছে? Okay, it seems there is someone watching. If someone is watching, please state your name in the chat so that I can watch. It's my first time. I'm excited, kind of. We will start at 9:15. There is 3 minutes more. anybody is here, please state your name in the chat so that I can see. Okay, so today we're gonna implement some basic things like dynamic arrays. So let's just start. Let's just create a main.c file and off we go. Standard io.h, everybody knows it. Well, it's just custom to start a project by hello world to check if everything's working. If someone is watching, they can interact with me in the chats to if you want to ask some questions or anything like that, I will respond. So let's just compile this file. Okay, it compiled, and run it. Hello world. Nice. So today we will implement dynamic array. So just let me define the struct for that array. So it will be a dynamic array that will hold integers. Let's just keep it simple. What is a dynamic array? It is array is already present in C. So what is special about dynamic array? It is just it's a growable array. If we push some element in the array, it will grow if needed, and if we delete the elements, if not needed, it will shrink with time. So that's just it. Dynamic array. It's very basic data structures in all the languages, but C doesn't have it. So we have to implement it from the start if we want to do anything substantial in it, like any projects, any simple projects. So let's just start simple. We will store the data that is the underlying array pointer, and we will store the length, and we will store the capacity. Okay, and we have to name it. Let's just name it simple int array, and we also have to type def it, or else we have to write struct everywhere. Okay, so let's declare a variable, and also write an initializer function. It just receives the array pointer and nothing else. So firstly we have to allocate some memories. So let's just define some default size of that array. Let's just keep it 16. Let's also write a function to debug the array so that we can print. It just receives the pointer. %p for pointer. And we will pass the corresponding values. Okay, so let's just try it for now. We have to pass the pointer. Okay. This is before initialization. We have to initialize it. And let's also print it after initialization. Nice and simple. Okay, we have to include the standard library. Okay, compiled. Okay, so before initialization, this garbage thing, and after it's working fine. Okay, so now we have to add okay, so in this add function we will just pass the pointer to that array and the value we want to add. That should add the value to the, so simply what will we do, it just increases the length and pushes the value to the stack. Not the stack, is the array. This is not stack, this is simple array. So okay, if somebody is watching this, can you please just write your name in the chat? I will be obliged. Okay. There's nothing magical in this. We have to grow the array if the length becomes the capacity or whatever. Hey buddy, Aniruddha, how are you? Yeah, I will keep going. Okay, so if the length becomes the capacity, we have to grow the array. That means we have to reallocate. So for now, we are gonna use the realloc function in the standard library. Later we can. Thank you, Aniruddha. Hello. Eta mana na. Okay, mana. Don't you have exam? Okay, so the realloc function just takes the pointer, the old pointer, and the new capacity. So we have to increase the capacity into some value. Let's just keep it for 2. We are gonna double every time the capacity surpasses. Okay, so let's just try it. Also, we are going to design a interpreter so that we can test these things in runtime. So let's just design a repl, and we are gonna pass the pointer. This repl function returns nothing. It just takes input from the standard input. Okay, takes input. Okay, so we have to take input from the standard input, that is the terminal. When we run the program, there will be a prompt. We can like give it some instructions to add some value or delete some value or whatever we want. So let's just keep it simple, and let's declare a stack. Okay, someone is calling me. Who is it? I don't know. Anyway, so let's just declare a buffer that will hold, and it will go on forever until you quit. And while takes any value. If it is 0, it will stop. It is non-zero, it considered true. So while 1, let's print something on the screen, an arrow that will give the user the prompt to type something, and then fgets. For those who don't know fgets, what it does, it just takes that buffer and it just puts some characters from the standard input or whatever file we provided to that buffer. So we provided with that buffer the buffer size, that is 1024, and what is an std input, that is standard input. Not buff, just buffer. And you know what, we should take this and make it a macro. Define buffer size 1024. These macros are just they are replaced here. We can use buffer size so that we get good old autocomplete, and also there is no error. Buffer size, okay. So the buffer size is 1024. It is on the stack, so there is no, and the while loop is going on here, so it's not gonna like deallocated or something, so it's fine for now. And we will pass it to some function execute. We will pass it the buffer and the buffer size and the array. Okay, and we have to write this execute function. Okay, so this execute function should take input a character pointer, that is buffer. Buffer is the character pointer. It's an array. So we should cast star buff or buff, whatever, and the size int n, and the dynamic array int array. Okay, so this execute function is gonna scan this buffer, look for any like operation we will define just shortly, and it will execute it. So let's just keep it simple for now. Let's just take the first character, that will be a character, op for opcode. So it will be the first character of that buffer, buffer 0, buff 0. Okay, and we write and switch expression op. So here we can define our various kinds of operations. So let's just keep it simple. Let's just if the first letter is A, we are gonna add some element to the array. Okay, so let's just print something. So always check if it's working. Printf add happened. Nothing is happening, but let's just print that for now. Add happened. what? Anyway, so let's just compile it. Oh, also, yeah, okay, so this is the array. We are printing it before initialization. We are initializing it, then we are printing it, then we are like passing the control to that function. Now this function does everything. Repl. Let's just see what it does. Repl. And compiled. Okay, now see, it is waiting for our command. Okay, so let's just pass it a whatever. Then it says add happened. Okay, so that's fine. Let's just quit. Okay, and also let's just for fun we should add a queue that should quit the program. And for quitting, we just use simple exit. Exit is defined in standard library. It is inside the standard library of C. Exit just exits the program. It is on operating system level. That's fine. Okay, add happened. Let's just add a new line character because it looks freakishly ugly. Oh, we have to compile it also. Okay, so if we type A and whatever something, it just said add happened. If we just type Q and whatever, it's not needed, but if we write something Q something, it just quits. How awesome is that? We are on the verge of creating the interpreter, the magical interpreter. Every interpreter works in this kind of way, actually, but this just this, where is it? Yeah, so what we are doing, just simple buff 0. In the interpreter there is some like sophisticated stuff. We will implement those kind of things, but for today these are good. Okay, so let's just implement the add. Okay, so when it is A, we are gonna add something to the array, and we will use this function, that is add entire. So we will pass the array and we have to pass the value. Like if we type here A45 and press enter, it should enter the 45 value to that dynamic array. Okay, so how we can get this 45? Let's just keep it very simple and very freakishly ugly. That is buff. We will use the A2 atoi. It just stands for ASCII to integer. It takes character and turns it into integer. We will pass it the second position of that buffer. Y. Okay, so if A is 0th position, then it's a space, that is first position. Then 4 starts from second position. If we pass a toi, that pointer to the 4, it will return everything whatever after that pointer is in an integer form. Atoi works in a weird way. It will also there are some variations, but this is fine for now. So we will get the 45 value from Atoi. If we like do something like a and whatever, like some error, then it is gone. uh, but let's just assume we do everything right. Okay, so after adding we should print it, because we should see it in real time, or where is the fun? Let's just print it. Okay, so in the printing side we are just printing the struct. We also have to print the values inside the data. So let's just write a for loop. I will run from 0 to length. Let's just print the elements for now. And give it a space, because it will be harder to. So, and we will pass it as data I. It's fine. Okay, so and just for beautification and aesthetics, I am very aesthetic, we should enclose it in a third bracket. Printf third bracket, and in the end printf third bracket. Okay, semicolon. Fine. And before printing we should check if the data is valid, because see, if we are printing before initialization, the data is nil, there is no value. If we're gonna like dereference this kind of thing, hell's gonna break loose. So we have to check if the data is valid or there is some data. So if our data is equal to null, that is it is uninitialized, we are just gonna return and do nothing. Eat 5-star and do nothing, just return. If it's not null, then we are gonna print whatever is inside it. And if it is something, we can assume that there is some length, so it is already handled. Okay, so now let's go. Let's just run it. What? Okay, so buff. Oh, we have to pass the pointer, not the value, the pointer to that value. Because Atoi gonna scan from here. I'm gonna call this Atoi. Atoi jol. Atoi, whatever. So let's just. Okay. Something's happening. Let's just A34. See, here it is printing A34 is here. If we call 56 is here. Okay, so for let's just delete this new line so that it doesn't go to the next line. If it is null, then we are gonna give a new line. Okay, fine. Now A34. See here 34. How awesome is that? Dynamic array. It's not dynamic fully because it can't shrink, it can grow. Okay, let's just check if it grows. the capacity is 16, right? We're not gonna enter 16 values. Let's just quit and decrease the array start capacity. Let's just keep it 4. See, the capacity is 4. Let's just enter 4 values: A45, 45, A12, cool, 76, cool, 10, cool. Now the reallocation should happen if we add another value. Okay, capacity is not increasing. Oh, we have to update the capacity also when we are reallocating. Bug, our first bug. Congrats. We have to update this capacity, or how else we are gonna know? Let's just quit and start again. Okay, now the capacity should increase. Yeah, it increases. See, the capacity is 8. It's working fine. And if we go on, it should grow. Every time it just surpasses the capacity, it should grow twice. 8, 16, 64. Now we should add the shrinking part. I know you can do it. I'm not gonna do it. This is a challenge for you. Do the shrinking part. Just add a function. Let's just create the function. Delete. If there is any question, you can ask it in the chats, man. Whoever is watching. Like if something is ugly, something is not right, something is bothering you, some problem, anything, you can just bring it on. Okay, so for deletion, we will delete. We want to delete something. How can we do this? Okay, so for add part, we are providing this value, that is we are adding. For the deletion part, we are not, we won't provide the value. We will provide the position. We will provide k, like here it will be k. We should delete the kth position, and however we can do it. Okay, so the simplest thing we can do is just decrease the length and swap the last character with the kth position. That what I'm saying is this: the kth position will be occupied by the last element. Well, this just fucks up the sorting order of that array, but if it is not that important, we can do it, and it's performant. It's just O1, constant time replacement. So the last position will be not our data length -1. So this is the simplest thing, and also we have to decrease the length. Okay, so we have decreased the length. Let's just test it. Oh, so we're gonna do the same thing with d. Here we will change this to D. We change the function to delete, and everything is fine, I guess. Let's just test it. 34 is added. 63 is added. 91 is added. Now let's delete D. We want to delete the 0th position, 34. That is 34. Now what should happen? 23 should come to this place, and 34 should be gone, and the length should be 3. So let's just delete D0. See how awesome is that? Okay, so delete is happening, and to make it dynamic, you have to implement the shrinking part. The shrinking part, I won't do it. It's a challenge for you. This will be similar. If the length becomes shorter than some value, you have to reallocate with the new value, like shrink it, like half it, or that's your choice, whatever you can do. The rule of thumb is like when it's growing, just double it. When it's shrinking, divide it by 3 or some greater than 2, because there is no meaning if just it becomes less than half. You have to then shrink again, then up again you have to increase it. This becomes tedious. Okay, our simple short interpreter is done, and our dynamic integer array is done, and we can do what we can do else. Let me know in the comment if we can do anything else, or we will end this vlog. This is not a vlog, this is live, I guess. This is streaming, whatever this is. Anything? One person is watching. Who is that? Whatever. So let's just end this. I will upload this to the GitHub. Okay, bye bye.